Hello. So just today we're going over add and subtracting monomials. If you have never heard this word before, please don't worry. I will explain in a minute. Here we go. As always, just a quick starter. Have a quick go if you can. We'll go through it shortly. Okay. Just a reminder then, when we add or subtract fractions or multiply or divide fractions that are mixed, you should be turn them into improper. So to do that, we do 2 times 3 plus 2. So that's 8 over 3, right? Because 2 times 3 is 6, plus 2 is 8. Keep the denominator the same. And then do 1 times 2, which is 2, plus 1, which is 3. So it's 3 over 2. When we have different denominators, we need to make sure they have the same denominators when we're adding subtracting. So we're going to multiply this whole one by 2. And then we're going to multiply this whole one by 3. And if you do that, then you should get 16 over 6. Take away 9 over 6. Times by 2 times by 3, right? And then just when you have the same denominators, you can just subtract. So you subtract that and you get 7 over 6. And we spoke about this before. You should then turn that into a mixed fraction. So how many 6s go into 7 is 1 with 1 over 6. There's 1 and then 1 remainder, which is why there's a 1 on top. Okay, for this, so we know that when we divide fractions, we keep change flip, but you cannot do that until you make them mixed fractions. Make them improper. So the 4 times 6 is 24, plus 5 is 29, over 6, divided by 1 times 3 is 3, plus 2 is 5, 5 over 3, and then we do keep change flip. Now remember, as you've seen here, I don't do the keep change flip until I've made them improper. If you try to do too much at once, you will make mistakes. It happens all the time. Okay, so KCF, we're going to keep the first fraction the same, so 29 over 6. We turn the divide into a times, we flip the last fraction to make 3 over 5. If we do that then, we do 29 times 3, which is going to be 87. We're going to do 6 times 5, which is 30. And then, as we did before, how many 30s go into 87? That's 30, 60, 90. Okay, so it's 2 with 27 remainder over 30. And then if you're very good, you recognize that 27 and 30 are both divisible by 3. So that gets me 2 and 9 over 10. If you got that right, well done. This thing on the right is just one of those things that I see all the time in random social media posts, like only 1% of the population can ever solve this, or if you can solve this in 30 seconds, you're a genius, all those stuff. So I grabbed it off one of those, and it's going to be quite helpful actually when we talk about adding what we're going to be doing today. So anyway, here we go. It says fish, I'll say jelly bean fish equals, I don't know, what's that, a lollipop? 26 take away lollipop equals watermelon. Watermelon plus watermelon equals 2. Okay, well, you know that both the watermelons mean the same thing, right? So if the watermelons mean the same thing, then they must be 1, right? Because 1 plus 1 is 2. So I'm just going to fill them in everywhere. Those are all 1s. And then if we look at the other things, you'll see that fish plus fish equals 10, because that's now 10, isn't it? Right, which means each of the fish are now 5. So 5 and 5. So I'm going to put that everywhere as well. And then what else can we do? Oh, we can find this lollipop looking thing, because 26 take away something is 1. So that must be 25. So I'm going to call that 25, which means this is 25. I'm going to write under it because it's not very pretty, is it? And then we have on the top, we have 5 plus jelly bean plus 5 equals 25. So jelly bean plus 10 is 25. So that means jelly bean must be 25 take away 10, which is 15, isn't it? Because 15 plus 5 is 25. So our final answer then is 25 take away 15, just looking at the bottom. 25 take away 15, which is 10. Now, this is one of those where when it comes to objects, most people are quite happy with doing algebra, because that's all this is, right? This is just algebra. I could call the fish F, I could call the jelly bean J, and I can call I don't know, is it a lollipop? I don't know. Call that L. And if I did that, a lot of people would be like, nope, can't do it. But the second you start bringing images into it, everyone goes, yeah, I can do that, it's easy. Oh, well, only if you're 1% genius or whatever Instagram says. Anyway, there's a method to my madness here, and we're going to go talk about that in a second, so here we go. So let W be the mass of a watermelon, or mass of a slice of a watermelon. Do we agree then that is a W plus W? And if I ask that, you would probably be like, oh, that's 2 watermelon slices, right? It's a watermelon slice, it's a watermelon slice, that's 2 watermelon slices. So with the images, you'd be happy to say that. With letters, I'm hoping you're okay as well. So W plus W, watermelon plus watermelon, is 2 watermelons, and that's fine. 2W then is a term made up of a few things. Let me get my pen out. So 2W is a term. Now a term we're going to talk about in a second, made up of a number, a letter, which is called a variable, and multiplication. So in other words, this just means 2 times W, right? It means 2 lots of watermelon, for example. Now the number is the thing in front, and a letter or a variable, depending on who you ask, is obviously the other thing. 2 is how many slices of watermelon we have in total. The number in front of the variable, so the number in front of the term, is called a numerical coefficient. Now, you don't have to know all of this, but coefficient in general just tells you the number that's going on, right? So how many slices of watermelon do you have? Oh, I've got 2 watermelons, so the coefficient is 2. Yep. So the numerical coefficient of 2W is 2. Good. Okay, so what about this then? So what we have here is we have 2 cherries, isn't it? There's 2 cherries there. There's 3 bananas. There's 3 bananas. Oh, 2C, sorry, 2C. 3 bananas, 3 bananas, and 3 bananas. Please excuse the way I say bananas. I'm obviously from a different place. Okay, so there's 2 cherries, 3 bananas, 3 bananas, and 3 bananas. Hopefully you're okay with the idea. It's 2C plus 3B plus 3B plus 3B. Now, if I was going to ask you to go to the shop, I don't know why I would, but if I was going to ask you to go to the shop and I say, hey, can you go get me 2 cherries, 3 bananas, 3 bananas, and 3 bananas? You'd be like, why did you say that? What a weird person. Why didn't you just say 2 cherries and 9 bananas? And notice how what we did there is we added the 2 cherries to the 3 bananas, 3 bananas, 3 bananas. We collected the 3 bananas, or 3 sets of bananas, to be 9 bananas, and then we just made it 2C plus 9B. What we didn't do is make that 11BC or 11CB or whatever, because if I asked you to go to the shop to get me 2 cherries and 2 cherries and 9 bananas, but said, can you get me 11 cherry bananas, you'd ask me, what am I talking about? And that's the same with algebra as well. So notice how we can't add the C and the B terms because they're different fruit. We call terms that we can add like terms. So all of these things that we're talking about, let me just highlight it again. All of these things, the 2C, the 3B, the 3B, the 3B, those are things called terms, right? And when they have the same letter, they're called like terms, and we can add or subtract them. So here's just another quick go. Right, we have, let's change color. We'll go, this is 2C, because 2 cherries, plus 2C, I guess, or I guess I should have called that 4C. Let's do that first. So let's go, so we have 4C plus 1W. Now you can either put 1W, or you can just put W, right? Because if I say, can you pass me an apple, I have never mentioned a number there, but you know that's 1 apple. In the same way, if I put AW, you know that's 1W. But for the sake of now, we'll just put 1W. Minus 2 cherries plus, again, we could put just W, but I'm going to put 1W just for the sake of it. If we looked at this, right, if I said, hey, go get me 4 cherries and a watermelon, actually, take away 2 of those cherries and get me another watermelon, you would know that would be 4 cherries take away 2 cherries is 2 cherries. And then 1 watermelon plus 1 watermelon is 2 watermelons. And the reason it's got a plus sign between there is because I said, get me 2 watermelons, right? Give me plus 2 watermelons. So 2 cherries, 2 watermelons, it's got a plus sign there because it's a positive watermelons. If we talked about the one underneath it, it's 3 bananas plus 2 strawberries. That is an S, not a 5. Plus 3 bananas. Take away 2 strawberries. Hopefully you agree that actually that is the same as me just saying 6 bananas and then no strawberries. Now you could put 0S, but while you're saying 0S, you might as well put 0A, 0B, 0C, 0D. There's no point putting 0 in front of a number that's not existing, right? So just to be clear, that is 3 bananas and 3 bananas, and then 2 strawberries and minus 2 strawberries. Now what you might notice here is even though there's random subtraction signs, those subtraction signs only actually affect the object it's behind. Or should I say, the object is only affected by the sign in front of it. So when we were doing the 4 cherries plus watermelon take away a cherry, we didn't think it was a watermelon take away a watermelon. It was a positive watermelon and a positive watermelon, and then a subtraction of the 2 cherries. And it's really important to understand the sign only affects the thing it's directly in front of. And that's quite important to have a look at. Okay, so up to you what letters you use here. For the sake of the argument, let's just call this an apple, let's call this a banana, let's call this a mango, and let's call this a watermelon. Assuming you're using these letters, have a quick go at this. Okay, so hopefully you had a go. So I'm hoping you were like, hey, this is a plus m plus a, and I can simplify that to be 2a plus m. Right, apple plus mango, 2 apples plus mangoes. I'm hoping you looked at this and was like, okay, this is 2m plus 3w minus 1w. Again, you can just write w if you want to. And so 2m plus 3w minus 1w, well, 3w minus 1w is 2w, so I have 2m plus 2w. And then the final one, we've got 2a, that's an a, plus 2b plus 2m minus w minus m plus a. So what do we have then? We have 2 apples plus an apple, which is 3 apples. We have plus 2 bananas. We have 2 mangoes take away a mango, which is plus mango. And then we have minus watermelon. Now, this part here is where the whole object thing kind of fall apart. Because if I never said anything about a watermelon, how can I take a watermelon away? And this is part of the reason that we say we try to get away from objects, because really, objects are confusing. I've just put 1m and 1w there just in case people like that as well. So we're going to try step away from objects, but I still have some questions with them just in case. So here we have just with no letters, with no objects, just with letters. So here we go. So algebra doesn't really use images. We use variables, right? Like terms are terms that have identical variables. So 3x, 2x, 5x, negative 2x, 100x, they're all like terms because they all have the letter x. It doesn't matter what their coefficient is, what the number is, right? They're all like terms. Whereas 2ab, 3a, 4b are not like terms. Yes, this has an a and this has an a, but because it has an ab, this is not the same as this. And even though this is a b and this is a b, this has a b, this has an ab. So these are the letters in this term. That's the coefficient. None of these share the same thing, so they're not like terms. And as we said earlier, we can only add or subtract things that are like terms. So here's some examples. So if I ask what 4x plus 10x take away 3x, well, hopefully you agree that 4x plus 10x is 14x. And then I'm going to subtract that 3x to get it gets 11x. Again, you don't have to do all of those and like that I've just shown you. I'm just teaching, right? You can just literally go, oh, 4x plus 10, that's 14. Take away 3 is 11. Okay, so 11x. If you have a bunch of terms together, hello, miss. If you have a bunch of terms together, then we have a 2a. Are there any other a's here? No. So I just have 2a. Then I have a positive 8b. Let's use a color. I have a positive 8b plus 11b. So I've got then 19b. And then I've got negative 10c, take away 7c. So that will get me negative 17c. And remember, you're taking away 10c and then taking away another 7. So that's going to get you negative 17. And again, we spoke about how the signs only affect the thing it's in front of, which is why it wasn't 8b take away 11b. It's positive 8b plus 11b, right? And then last but not least, if you get one like this and there's got a bunch of letters that don't have a number in front of it, just remember there is technically a 1 there, and you can write that if that helps. So what do we have? We have 6p plus 1q take away 6p plus 20q. So 6p take away 6p is nothing, so I'm not going to write anything. And then I have 1q plus 20q, which is 21q. And it's absolutely okay for letters just to go missing because sometimes that happens, right? Okay, right. So there are a ridiculous amount of questions here. I am going to go through some of them, but in general, the skills levels are pretty simple. You've seen the tests a lot now, I hope. So the way it works is the first page is your level 1, kind of level 2 skills. Your second page is like your level 3. And then the last page is like your level 4, just absolute nonsense, absolutely crazy. I'll go through them very quickly, but have a go. So I'll leave this up there for 10 seconds and I'll go through. I'll leave this up there for 10 seconds and then go through. And you know how to pause it and then go through. And then we'll very quickly talk about squares. Okay, so very quickly, let's do this. So how many cars do we have? We've got 2 cars and 3 planes. So 2C plus 3 planes, I guess. How many tomatoes do we have? 1, 2, 3, 4. So it's 4 tomatoes and 3 onions. We've got 7 pizzas, take away 3 pizzas, that's 4 pizzas. And then we have 4 juice boxes plus 5 juice boxes, that's 9 juice boxes. That's supposed to be a 9. Which of these are like pairs? Well, 6x and 14x, they're like pairs. 10x and 10y are not like pairs. Negative 5a plus 10a are like pairs. Negative 9x plus 5 are not like terms. They have to have the same letter. If there was a 5x, it'd be like terms, but it doesn't have, it's just 5. State the coefficient, it's just a number, so it's going to be 8, 15, Negative 4, remember there's technically a 1 in front of this one, and there's technically a negative 1 in front of this one. And then simplifying, we have 4x, we have 7y, we have 3x plus 4x plus x, 1x, right? Plus 1x is going to be 8x. 9a take away 5a is 4a, plus 4a is 8a. I'm just going to change colour to make it easier to follow. 2x plus 6x is 8x, take away 8x is 0. 3k take away 7k is negative 4k. W plus 5w minus 9w, remember that's a 1w there, so it's going to be 6w take away 9w, which is negative 3w. And then 2z take away 10z is negative 8z, plus the 7z. Nothing's working on my thing. Negative 8z plus 7z is going to get us negative 1z. Cool. Okay. On this one, is she correct? Nope. That if it was 2x, she'd be correct, but it's not, so nope. They've got to be like terms. So if we're going to add this, 9x take away 4x is 5x. Positive 3 take away 10 is negative 7. So there's nothing wrong with 5x minus 7, that's right. And there's technically nothing wrong with 5x plus minus 7, but as we talked about before, plus minus means minus. So it's just 5x minus 7. You would still get marks for this, but it just doesn't look as pretty. And then last but not least, this is so a plus minus means minus, so it's negative 5x plus 6x, which is 1x. Take away 3x is negative 2x. Negative 8x plus 2x, it gets you negative 6x. 16x plus 1x is 17x. Negative 4y plus 12y is positive 8y. Negative a plus 4a is 3a. Negative 9 plus 15 is 6. 4x take away 9x is negative 5x. Negative 3 plus 6 is plus 3. And then 2 plus 9 is 11. Negative 4m take away 11m is negative 15m. I'm going to very quickly go through this page. So a bouncy castle is $300 plus $100 an hour. So they say use t to represent time in hours. So it's going to be $300 no matter what, plus 100 times how many hours? So 100t, right? 100 times 1 if it's 1 hour, 100 times 2 if it's 2 hours. A clown is $25 per hour, so that is just 25 times t. That's supposed to be a t. Yep. And the cotton candy machine is $125 no matter what, plus $75 times t. The total rental cost then is just going to be 300 plus 125 is 425. 100t plus 25t plus 75t is 200t. And then if Rosie needs to use the item for 5 hours, we're just going to put 5 into here. So it's going to be 425 plus 200 times 5. That's 1,000. So it's just going to be 1,425. Okay. What's happening? Please give me anything back. Okay, so hopefully that makes sense. Right, last part, this is probably level 4 stuff, just really very quickly going through this. If you remember that x squared is actually x times x, then you realize that x squared is not a like term of x, right? I appreciate the concept that they have the same letter, but they don't. X squared is actually x times x, that's using x twice. So those are not like terms. So when you see terms with the same letter but different powers or exponents, we cannot collect them. They cannot be collected because they aren't the same. So just in the same way we can't collect 3a and 2b, we cannot collect 3x squared and 2x. You can't do anything with them. So very quickly, here's the examples, and then I'm done. 3x squared plus 4x squared is 7x squared. Positive x minus 5x is negative 4x. And then last but not least, negative 12 plus 1 is negative 11. Even this horrific thing, this is properly horrific. I've got an x squared y, then I've got xy squared. They're not the same because the x is being squared in the first one. The y is being squared in the second, yeah? So x is being squared here, but y is being squared here. This one has no squares. This one, both of them are being squared. We have another x squared y here, and etc., etc. So I'm just going to quickly highlight the ones that are the same. This is 7x squared y and 3x squared y. So that's 10x squared y. Then we have negative 4xy squared. Are there any other xy squareds? Yes, there are. There's a plus 8xy squared, so that's plus 4xy squared. Then there's a negative 9xy and a negative 6xy. That's negative 15xy. And then we have, finally, the plus 3x squared y squared, where there is nothing else. So it's just 3x squared y squared. hopefully that makes sense. Have a quick go at these, and then we're done. Okay, so this should have got you 6x squared plus 18x. This should have got you 17x squared plus 3x. This should have got you 5y, because negative 3y plus 8y. And then 4y squared take away 7y squared is negative 3y squared. Then we have negative 20x squared take away, remember that's a minus, plus minus a minus. So that's 4x squared, so it's going to be negative 24x squared. 4x take away 5x is minus x, or minus 1x if you want to. Negative a squared plus 10a squared is 9a squared. Negative 3a plus 5a is plus 2a. And then x squared plus x squared is 2x squared. And negative 4x take away 3x is negative 7x. Bit of a longer video today, but hopefully that all makes sense. Have a good day.